In this example, we're going to be using the distance formula to tell whether segment PQ is congruent to segment QR. It's a good idea to write down the distance formula beforehand on your paper so that you have it for referencing. The first segment we're going to find the length of has to do with P and Q, segment PQ. So in this case, I'm going to use this as my second coordinate, and this is my first coordinate. So this is going to be x2, y2, and this is going to be x1, y1. I chose this because I knew it would be easy to subtract 4 minus 1. But it doesn't matter which one you use as your first coordinate or your second coordinate. So, the length of PQ is equal to the square root of x2 minus x1, 4 minus 1, squared, plus y2 minus y1. It's important that you keep your negative sign straight because that could be confusing in the end. So, when I simplify, 4 minus 1 is 3, and negative 4 minus a negative 6 would be the same as saying negative 4 plus 6, or 2. So PQ has a length of 9 plus 4, square root of 13. The length of PQ is the square root of 13. To find the length of segment QR, I'm going to do just the same process. I have erased my x2, y2, x1, y1 because I'm going to rename them. In this case, I'm going to have this one as x1, y1, and this one as x2, y2. Therefore, to find the length of segment QR, I'm going to use the distance formula to say this: x2 minus x1 squared plus y2 minus y1. Once again, I am careful to keep my negative sign straight so as not to get confused. Now I can simplify. Negative 1 minus 1 is a negative 2 squared. A negative 3 minus a negative 6 is the same as negative 3 plus 6, or 3 squared. And when I simplify my square root, negative 2 squared is 4, and 3 squared is 9, so I get square root of 13. So the length of PQ is the square root of 13, and the length of QR is also square root of 13. So we can say that segment PQ is congruent to segment QR.